Good afternoon, everyone. Thank you for joining me for the interesting and exciting topic as we are delving into ML Ops, where machine learning meets operation. ML Ops is a very simple and a bit complicated term because if you want to productionize your model, you have to deal with multiple teams. When we talk about data teams consist data engineers, BI engineers, ML engineers, data scientists. And if you are productionizing your model, you have to talk to business users also. When any model is built in traditional machine learning, data scientists build on experimental fees. So they just use sample data, decide about data science model, and it's just the solution of the problem. But if you move that model into a production environment, we face multiple challenges. And to tackle those challenges, we require certain best practices. Today, I will be talking about those best practices, the way we have productionized our model in NTUC. So basically, there are 6 steps. One step, collaboration and communication is really important, as I just talked about it. So at each step, we need to talk about business users, data engineers, BI engineers, data scientists, about our model, at what step it is. First, infrastructure and environment management. And second step, feature engineering, data management. Then third step, model versioning and deployment. The fourth, monitoring and performance tracking when we deploy our model. And the fifth is model governance and compliance. All these are critical steps, and I will talk about each step in detail. For infrastructure environment, there are 3 most important things. One is scalable cloud infrastructure. Second, containerization and orchestration. Third, development and testing environments. As we know, there are multiple cloud environments, and each provides different options. So if we talk about cloud platforms, we have AWS. AWS provides SageMaker. Google provides Vertex AI. Azure provides Azure AI. All these platforms provide different APIs, different platform to monitor our models, do performance tracking. So we prefer them. And the other feasibility using cloud platform, we can scale up as per resources. Sometimes we don't require that much resources, and sometimes we require 800 GB of resources. So scaling becomes very easy when we use cloud platform. Then second, containerization and orchestration. These are the 2 crucial components of MLOps. First, I talk about containerization. With the name containerization, it's very simple. We are talking about a container. So in container, we put our ML model, we put our requirements, we put our configuration, and we create container. For containerization, we use Docker. Now we have created our container. We need to move it to production. So Kubernetes helps into that. Kubernetes does orchestration. For orchestration, okay, I take example of a conductor who is conducting very good music. So conductor knows which instrument and when it should play, and what should be the volume, whether it should be high or low. He orchestrates it. So if we talk about Kubernetes, Kubernetes does the same thing. And here, at the place of musician, we have computer programs. Now, third, development and testing environments. Here, I just want to differentiate about different environments. Sometimes we need to have multiple environments to test our models because we need to iterate it. We need to make our model up and running with better prediction. And to iterate, we do iteration in testing environment. Costing is another important term. If we uh, train our model in production environment and using huge amount of data each and every time, then the cost will shoot up, and the end of the month, our manager will chase us. From this slide, there one more question comes, why we are talking about cloud platform, whether machine learning model cannot be productionized in on-premise. Yeah, it can, but there are different scenarios. If a company has purchased enough amount of infrastructure, they don't want to migrate on cloud, definitely they can use on-premise infrastructure. Sometimes if they need data in their system, too much privacy concern about data, then they don't want to go to cloud environments, that's okay. The same application can be used on-premise also. The second most important feature engineering. Sometimes you might be thinking, why feature engineering so special, and what is feature? So feature engineering is very crucial part of MLOps. What are the features? If we talk about recommendation model, we talk about user feature. We have user ID, we have age, we have it's a purchase behavior, which area the person is living. If we have item SKU, so which SKU he needs to be getting in his recommendation, what is the popularity score of SKU. All these features we need to have, but sometimes we need to curate very important features like purchase behavior of last 2 years. So if we are checking purchasing behavior of a user for last 2 years, we need to scan very heavy tables, like sales line, which contains terabytes of data. And when each time every data scientist or every data science model will be getting that feature, it will be too much costly. So we run those jobs and we save the data inside our infra. Let's say if we are using GCP, we save that in BigQuery, and so that we save some cost accordingly. And other data science model can be utilized on top of it also. Now, these are the basic steps: data cleaning. If your user ID we have created as feature, we need to be aware. We should not have null values. Now also, what is ML models? Whether it understand numerical feature or categorical feature. So many of ML models does not understand categorical feature. We need to do one-hot encoding or contribute into numerical feature. So if I talk about one-hot encoding, so if I live in Sengkang area, I just create a feature, age Sengkang, and I will check in front of my name, Shiwam, and then 1 or 0. Something like this we create in feature. And these are a bit resource-intensive things. So we save all these features inside our feature store, and time to time, other data science model can be also using all these features. Feature transformation, encoding categorical variables, feature creation, extraction. Sometimes we require domain knowledge also. With the domain knowledge, let's say if you are using e-commerce industry, you are aware Sunday on Sunday sale will be a bit high. If something festival is coming, our sale be a bit affected because of it. Some type of user will not be using, so data might be less. So we know about the domain, and we curate feature accordingly and put them in our ML models. Now, sometimes we need feature interaction. What is feature interaction? Feature interaction or derived feature is like we curate some more feature. Let's say I have height, I have weight. I create new feature, that's a BMI, and it can be helpful for our ML model. So such type of activity is being done in feature engineering arena. Now, model versioning and deployment. So versioning is very important. When we deploy our model, we need to be aware which version it is. If you don't know which version it is, how it is behaving in production environment, then rolling back becomes difficult, or tracing the performance becomes very difficult if we want to roll it back. So versioning is very important. For that, we use Git, Bitbucket repository, and for the best practices, whenever we do any commit, we put proper message, like we have changed all these things for this version. Model packaging, I just talk about Docker container. So this is something like that. We do containerization, and we push our model in production environment with the environment variables. Now, third step is deployment automation. When we deploy our model, first time it's okay. But let's say 40 of models are being deployed, and sometimes changes are being done. Most of the steps becomes redundant. And if we are doing it manually, we can make multiple errors and waste our time doing same thing again and again. So we can set those variables which are being used in our Bitbucket repository, Git, and we can do some automation to save some time. So A/B testing and canary releases. A/B testing and canary releases are very important when we are productionizing multiple models. So A/B test basically we perform to check which version of model is giving better performance. So we do such type of case, like deployment, considering A/B testing. Canary releases. Canary releases is a bit different from A/B testing. Canary release is basically deployment methodology when we deploy a model for very sample, very less amount of data. And we think, okay, the model is doing okay. Then we put this for all the data set. So a big chunk of data is being used for this methodology. This can be also applied. Monitoring and rollback. Sometimes we found, okay, we deployed this version, and this version is not doing okay. The monitoring parameters are giving something unavoidable problem. The model is being failed in production environment. We need to roll it back. And if we are properly following methodology, we can roll it back in just 2 minutes. So if we follow this, it makes our life easy. Monitoring and performance tracking. Now our model is up and running in production environment. Most of the people think, okay, now model is deployed, my life is okay, I'm enjoying. But the critical work starts from here. We get real-time data, real-time monitoring. Let's say I talk about recommendation model. If it is in production environment, how it is behaving. We need to get some metrics around that so that we say, okay, model is behaving good. So few of the metrics, click-through rate, CTR, we can see conversion rate, this new model is behaving properly or not, our conversion rate is increasing or not, average order value is increasing or not. So these parameters help us to understand accuracy and error metrics. Basically, this second component is to understand model drift. If model is not behaving as per our expectation, if model is not giving correct result, we need to get some data around it so that we can train our model again with new data. So we need to get accuracy, precision, recall, FN score. I just took example of classification model. Latency and throughput. This is also very important metric. So let's say we have deployed a model and it is giving result and taking much time. So latency is too much, but we require very less latency. So sometimes our model becomes unuseful if it is taking too much time. Or throughput is very less. The model is not able to handle so much request. So there's no use of deployment. So we need to have those numbers, and we need to set it when we need to roll it back. Drift detection. Drift detection, in simple example, I talk, okay, if a model, let's say linear regression model is deployed, and as a feature, I put salaries like $100, $200, $500. I didn't use $1,000. And after some time, I started getting data $2,000 as the input, and I need to predict something. I never trained my model using that data. If my model is getting such type of input, it will deviate. It will give some random result. So we need to have a proper methodology to detect whether the data we are getting, it's okay or not, or we need to retrain our model. Sometimes in companies, they do retraining of model often, so they don't require. But it becomes very useful when we train our model, which takes days to train, and very heavy resources to get trained. So we save some cost accordingly if we do early drift detection. User feedback, business metrics. Last point, so let's say I am putting recommendation model, people are getting a recommendation, so we can get some feedback also whether the recommendation they are getting it's okay or not, or we can also check the sales revenue is going up or not. So such type of metrics help us to understand more about the deployed model. Now, model governance and compliance. This is the last step. So for this, we have 5 major points. Ethical consideration. When any model is deployed in production environment, it should not have any bias when suggesting something. So let's say I have deployed a model and it is providing dynamic pricing. So dynamic pricing should not be based on any person's race or the personal criteria. If it is considering that or somehow we are getting a result accordingly, then we need to consider retraining our model or understanding what features are creating that problem. A regulatory compliance. So data protection, privacy regulation, we need to follow. We don't need to use PI data because if you are using PI data, then our ethical consideration will also get affected. So we need to avoid PI data, personal information. Documentation and model explainability. When we deploy a model, sometimes we do all the technical stuff, but we don't document about it. What features are being used, what data we got, if we use these features, if we are avoiding these features, whether the performance will improve or not. Such type of documentation should be there. Model explainability. Model explainability is a very key parameter, and it can be understood from the feature importance and shapely values. The Python packages helps us to get those values, and we can just put some threshold and understand whether the model is explainable or not. Model performance monitoring, in our previous slide, we talked about it in detail, but we need to have some threshold value, and in governance, we can set those values, whether we need to retrain our model at certain stage or not. Access control and security. Our models are very precious, our features are very precious. We should be aware who are accessing, who has the right to access our features, whether someone can just delete our model or put some different version of model, we should be aware about it. So we need to provide particular person access to that cloud storage bucket. Not everyone can access. These things we need to take care. Thank you everyone for listening to me.
Thanks, everybody. All right. Thank you very much, Mr. Shiwam. Does anybody want to give a quick question before? Okay, we do a quick question right here for you. Yeah?
Hey, thanks a lot for all the insights. Very interesting. I have a very technical question, I would say. When we look at, for example, Azure Machine Learning space, and when we do model inferencing, deploying via Azure Machine Learning, it's quite pricey to deploy via Azure Machine Learning or the Machine Learning workspace. Are there any kind of scenarios where it makes sense to, for example, build the model but not host it on an Azure Machine Learning space, or let it be Google Machine Learning space, but rather develop that model in your favorite language of choice, containerize it, and then deploy it in a virtual machine or in a container without the overhead of a Machine Learning Studio resource?
Thank you for the question. If I understood clearly, you are asking we can use Python or any other language. We don't use like Vertex AI platform or Azure AI, and we can deploy our model. That's what the question, right? Yeah.
Always have to retrain, and we always use the latest model. And what we figured, at least in our scenario, is that the cost of doing then a deployment with a Machine Learning Studio instance, for example, are significantly higher than just letting the model run on a very small machine or in a Kubernetes cluster compared to a deployment as a service or a model as a service. And I'm just wondering, like, is this the right approach, or is it always better to have the model deployed in a regular MLOps cycle? Because obviously you also have the other advantages like monitoring data drift and model governance and whatever. Because in our case, the model is every month new, and then the model governance is, so to say, out of control.
So if we set these MLOps methodology and we are dealing with multiple models, and we need to deploy it frequently, then these helps us. If you're just talking about 1 or 2 models, so that's okay. We can follow our manual process and we can avoid something. But these really helped us when we deployed 40 plus models and we are doing regular updates.
So essentially, if the model magnitude is manageable or low, it's possible to skip the regular
if you want to test it something, then initially you can skip some of the steps. But yeah, few of the things becomes really important. What type of features you are using? You need to avoid PI data. You don't need to use it. Somehow, if it comes into data governance category, then data governance people will object it. Yeah. So these things are really important.
Thank you, sir.
Yeah. You can skip some of the steps. Thank you.
Anybody else for one more question? We can do one more question.
Hey Shiwam, that was a nice presentation.
Thank you.
I would like to touch upon one point which I think is missing, maybe, probably which you might have covered in a very different connotation about the model improvement. In your what I see is model improvement to be a part of a manual process rather than an automated process. Is that right understanding, or is there an automated model improvement that you are also suggesting?
So for model improvement, features plays very important role. Whatever input we are giving, our prediction will be dependent on that. So for that, we need to take any model as a separate category, and we need to deep dive why we are getting the particular result. It cannot be into automated process. Yeah. Thank you.
Perhaps we'll do just one more last question. Yes. Over to you, sir. And for the rest of the other questions, feel free. We're having a networking session that happens later, and it doesn't have to be a one-on-one. It can be with a group as well, and we can enjoy that lovely networking together. Next person.
Hello. Yeah. Thanks for the sharing. On your last slide, you mentioned about the model governance and the compliance. I just have the questions on the ethical the conditions. Actually, can you elaborate further how it's being done? Is it like involving humans assessment to see whether the outcome is ethical or not, or there is some sort of automated automations is in place?
For this, generally the recommendation, let's say we talk about recommendation, and whatever recommendation you are getting, if particular groups from the data we observe getting similar type of recommendation all the time, and people are not following that. Let's say I recommend you Meiji milk, and you don't take it, but we are giving it to again and again. So such type of things, if some racial thing or coming into picture, if we observe the data, then we need to think about our model, retrain it, or we need to check which feature is contributing to it. So such type of things needs to be done manually after looking at the data, the predictions. Yeah. For now, we are doing manually.
Thank you very much. Very insightful. Ladies and gentlemen, Shiwam Divedi, everybody.